This is a pretty cool optimization question. There's the concept of overcrowding here. So the situation is that you have an acre of land to plant walnut trees. So each walnut tree will produce about 50 pounds of walnuts per year, as long as you don't have too many trees. So the moment you start having too many trees in the same acre, the trees start to compete with themselves, for materials, resources, water, minerals in the soil, stuff like that. Just sunlight as well if there's too many. Overcrowding just makes the production of every single tree decrease. So how do I account for that in my model? That's what I'm trying to do, right? So on A, they ask us to represent the yield per tree, so per tree in pounds, as a function of the number of trees. So based on what I just said, there are two different situations, right? There's the situation in which I have fewer than 30 trees, or 30 trees or fewer. And in that case, we're told that each tree produces about 50 pounds in 1 year. So that's 50. Okay, y of x equals 50 if x less than or equal to 30. That is fine so far. That is the easy part of item A. Next, we want to see what will happen when we start having overcrowding. So when we have too many trees. So starting on the 31st tree, for example, what we have to do is account for the 1.5 pounds less of walnuts that are produced per tree. So each one produced 50 at 30. But when you have 31 trees, then now you subtract 1.5. Okay, so it's 48.5. If you have 32 trees, right, you have subtract 1.5 again, so it's 47. And so on. You subtract 1.5 as many times as you have extra trees, right? So if I were to model this, I would have 50 minus 1.5 times the number of extra trees that I have. So that's x minus 30. When x equals 30, there's no extra trees, so that is a 0. That goes away, nothing changes. But when x is, say, 31, then 31 minus 30 is 1. So 1 times 1.5, I subtract just 1.5. You'll see that that will happen. That will work with all the other values as well. So that's what I have. And I'll just use distributive property just to make this thing look a little better. So that's negative 1.5x plus 95. So negative 1.5x plus 95. And that's if x is bigger than 30. Okay. This is just scratch, just thought process here on the side. Don't need to do these exactly like I do, but do write something so I know how you're thinking. Always try and show your reader how you got to the conclusion you got to. Don't just write the answer. That's never good. Now on B, so remember on A that was the answer, that was the yield per tree. On B, we're expressing the total yield for the entire acre. So on the acre we have x trees, right? So T of x is however many trees we have on the acre times however many pounds each tree produces. So x times y of x. Okay, take a second to understand why that is. Just multiplying the two. And then we use this expression for y of x, but then multiply by x because it's x times that. It's pretty easy. So 50x if x is less than or equal to 30, or minus 1.5x squared plus 95x if x greater than 30. So that is B. Now on item C, I'm asking you to find t of 10 and t of 40. Note that these are values that are in the different parts of the piecewise function. So this function has two parts, the two pieces. This top piece applies to the t of 10, and this bottom piece applies to the t of 40. So I want to make sure that you took care of that multi-part, this piecewise definition of the function. If you didn't do that, then you're going to get this question wrong. So make sure you're careful. T of 10 is fine. T of 10 is, okay, 10 is less than or equal to 30, so I use the top part. So that's 50 times 10. So that's 500 pounds. Always use your units of measurement. Doesn't hurt to use them. And then T of 40. 40 is bigger than 30, so I use the bottom definition. So that's minus 1.5 times 40 squared plus 95 times 40. So I got to be careful with your calculator here. So let me bring it up so I could help you. Find my calculator. Here it is. So let's do this math together here so you don't get confused. I'll do negative 1.5 times 40 squared. That's fine. Plus 95 times 40. Double checking to see if I haven't made a mistake anywhere, but I think that is okay. That is 1,400 pounds. Okay, so that is way more trees for sure. I could definitely change this question and maybe make it T of 20, T of 25, T of 35. So make sure you're familiar with how to do that kind of stuff in your calculator. I could ask 31, like 33, 28, any number. So make sure you're able to use your calculator for that. In those cases, the numbers will be a lot closer, right? 25 and 35 would be a lot closer than 10 and 40 are right now. So on D, which is the last item, use your knowledge of quadratic functions to determine the optimal amount of walnut trees to be planted if we want to maximize the yield for the acre. So we have the situation here, right? Actually put this away. Maybe I'll need it later on, so I'll keep it for a second. We have a situation. We have this part of the function, which is an increasing line up until 30. And then we have a, here at the bottom, a concave downward parabola. And we actually don't know if that's what the graph looks like. We don't know if the highest part is here or if it's here. You know, maybe the parabola was like this or something, right? It was just like that. So maybe the highest part was here. So I gotta check, gotta see. So I gotta check that by noticing both parts. So in the 50x part, if x is less than or equal to 30, what is the highest this could possibly be, right? So I'm multiplying 50 by x, so the highest I could have is 50 times 30, because x could be at most 30. So this is 50 times 30, so that's 1,500 pounds, and that is the best results on this half. On the other part of the function, the green part, I'm dealing with minus 1.5x squared plus 95x when x is greater than 30. So this is a quadratic function, and the maximum value here that I have is minus b over 2a. So that is the x of the vertex, right? That's the number of trees that gives me the correct answer. And that is minus b over 2a. So minus 95 over minus 3. We're rounding to the nearest whole number, so I gotta check, how many trees that is. So 95 divided 3, that is approximately 32 trees, pretty close to the turning point. And here I have 30 trees. So which of the two will give me the most yield? I know 30 gives me 1,500 pounds. How many do 32 give me? So let's turn that up. Let's see what 32 is. 32 gives me this formula. So I got to use the same formula I used before, now with 32. So So 32 squared. Be careful with what you're doing. Don't make a mistake on that part. And I get 1504 pounds. So that is definitely bigger. So I'll box the answer just so it's clear. And maybe I could write something. This graph here is not necessary, but if you want to put it here, you can make it a little smaller just so you have more breathing room here. And I can say the optimal amount of trees is 32. Make sure there's no room for error here as well. You have to check both parts so you get two numbers for sure. Make sure you're clearly identifying which one is the correct answer.